Hello everyone, welcome to my YouTube channel. This is Chaitra, studying in Sri Venkateswara College of Engineering, Vidyanagar, Bangalore. I am pursuing my first SEM BE in Computer Science and Engineering, Cyber Security. Today I am here to present you the subject Applied Chemistry for CSE stream, the first SEM. Let's have an overview about today's topic. Today's topic is all about corrosion and its types. Moving on to the next slide, we can see what is corrosion. Before moving on to corrosion, I request you to take a pen and a paper and note down the points. The corrosion is nothing but the distraction or loss of metals or alloys by the surrounding environment through chemical or electrochemical reactions. For example, rusting of iron, a reddish brown scale on an iron objects, green scales formed on a copper vessels. Corrosion may occur either in a dry environment or in an aqueous medium. The former is called dry corrosion and later it is called as wet corrosion. Now let's start with dry corrosion or chemical corrosion. Dry corrosion involves the direct attack of metal by the dry gaseous mainly through the chemical reactions. It occurs by the direct attacks of atmospheric gases such as hydrogen, oxygen, sulfide, halogens, sulfur dioxide on the metals forming the oxide layers. Example, the attack of dry air or oxygen on a metal to form an oxide layer over a metal surface. This process is known as dry corrosion. Moving on to the next slide, we have wet corrosion that is also called as electrochemical corrosion. Wet corrosion involves the reaction in the aqueous solution medium. The conducting surface of a metal undergoes an electrochemical reaction with the moisture and oxygen present in the atmosphere. Example, rusting of iron. The overall process is called as wet corrosion or the electrochemical corrosion. Now let us know what are the types of corrosion. First one is differential metal corrosion, then differential aeration corrosion, waterline corrosion, and pitting corrosion. Let's talk about differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as anode and undergo oxidation and gets corroded, and the other metal with higher electrode potential acts as cathode and remains unaffected. This type of corrosion is also known as galvanic corrosion or differential metal corrosion. For example, nails. For in the picture, we can observe that nails affected from the corrosion. This is due to the part of nail exposed to a lower electrode potential where it acts as anode and undergo corrosion. This is also called as galvanic corrosion. Now let us talk about differential aeration corrosion. When a metal is exposed to different concentration of air or oxygen, part of metal exposed to lower concentration of oxygen will become anodic and undergo corrosion, whereas the other part of metal exposed to higher concentration of oxygen become cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. In the picture, we can see that a part of nail which is immersed in water and the half part of the nail which is exposed to oxygen. The part of the nail which is immersed in the water which acts as anode and undergoes corrosion. The part of nail which is exposed to higher concentration of oxygen acts as cathode and remains unaffected. Now let us talk about waterline corrosion. It is observed in a steel or water tank partially filled with water for a long time. The inner portion of a tank below the water line is exposed only to dissolve oxygen, whereas the portion above the water line is exposed to more oxygen. Thus, the portion below the water line acts as anode and undergo corrosion. The upper portion acts as cathode and remains unaffected. In the picture, we can observe that the tank, which was partially filled with water for a long time, the inner portion of a water tank below the water line is exposed to dissolved oxygen and thus it is affected from the corrosion. Now let us talk about pitting corrosion. And pitting corrosion is nothing but this type of corrosion is observed when dust particles or oil droplets deposited over a metal surface. Pitting corrosion is due to metal surface is not homogeneous, external environment is not homogeneous, crystallography directions are not equal in reactivity, environment are not uniform with respect to concentration. Pitting corrosion results when a portion of metal covered by dust which is less aerated becomes anodic and undergo corrosion and forms a pit. The remaining area of a metal which is exposed to higher concentration of oxygen becomes cathodic and remains unaffected. Once a small pit is formed, the rate of corrosion increases because of the formation of small anodic area that is pit to corrode faster because accepting electron from the cathodic area increases. This is known as pitting corrosion. We have discussed what is corrosion and we know what are the types of corrosion. Moving on to the next, let us know how to control the corrosion. Corrosion control methods. Corrosion can be controlled by preventing the formation of galvanic cells on the surface of the materials. The methods to control corrosion can be classified as: first one, design and selection of materials. Second one, protective coating. In protective coating, we have classified it as two types. That is, first one can be classified as inorganic coating and the metal coating. Next is cathodic protection.